7 million years. I mean, just think about that. That is the length of our story. It is an epic journey of survival, of innovation, of connection. And it all leads, somehow, right here to us. So today, we're going to try and trace that absolutely incredible path.
Okay, let's kick things off with a number. A number that connects us, right now, to our closest living relatives on this planet, 98.4%. That is how much of our DNA we share with chimpanzees. It's just a staggering similarity, right? And it really anchors our entire story firmly in the animal kingdom.
So, what about that other 1.6%? Well, that tiny little genetic sliver, that's where the magic happens. That's where our entire epic story unfolds. It's a story of divergence, adaptation, and just sheer survival that played out over millions and millions of years. And you know what? It all starts with one single decisive split.
All right, so to really understand ourselves, we've got to go way, way back. We need to find our place in this vast, sprawling family tree of life, and we need to pinpoint that exact moment, the moment our own unique branch started to grow.
So take a look at this timeline. It really puts our whole story into perspective, doesn't it? For tens of millions of years, our ancestors were, well, just primates. Then they were apes. The journey that is uniquely human, our journey, it doesn't even begin until that final split from the chimpanzee line. And that happened somewhere in Africa, roughly 7 million years ago.
Okay, so that big split from our chimp cousins, it was driven by something truly revolutionary, a new adaptation. And I mean, this change was so profound, it basically set off this chain reaction of changes to our skeletons from the top of our heads all the way down to our toes.
And what was that revolutionary change? Bipedalism. Simply walking upright on two legs. It sounds simple, but this is the single most fundamental shift that defines our entire lineage. It's the whole ballgame. And some of our earliest evidence for this comes from ancestors like Australopithecus afarensis. You've probably heard of the most famous one, Lucy.
Now this shift to walking upright, it wasn't easy. It forced a complete redesign of our skeleton, and you can really see the trade-offs right here. The pelvis, for example. It had to become this short, sturdy bowl just for stability. The spine curved into that classic S shape to act like a spring to absorb shock. And even the hole at the base of the skull moved forward to balance our head right on top of our body. I mean, we were literally rebuilt from the ground up.
But here's the thing, walking upright had this totally game-changing consequence. Think about it. Once our hands were freed up from walking, they could be used for something completely new, making things. And this right here kicked off an absolutely extraordinary feedback loop between making tools, what we ate, and, you guessed it, the growth of our brains. And this leads us to a new genus that appeared around 2.8 million years ago, Homo. Yep, that's us, our very own genus. And its first really well-documented member was Homo habilis, a name that literally means handyman. And for a very good reason, too, because this was the species that really got the ball rolling on making consistent stone tools.
So, the arrival of our genus Homo, it marked the beginning of what scientists call encephalization, which is basically a fancy way of saying a massive, unprecedented brain-building project. Seriously, look at this. Our cranial capacity almost tripled from our earlier ancestors to us. But here's the catch. This new, bigger brain was an energy hog. It demanded way more fuel, which, in turn, created pressure to develop even better technology to get that fuel. And you can see that technology evolving right alongside our brains. We went from these pretty simple Oldowan choppers made by Homo habilis to the beautifully symmetrical Acheulean hand axes of Homo erectus, all the way to the incredibly specialized blades and even bone needles of our own species. It was that perfect cycle, right? Better tools meant getting better food, which fueled bigger brains, which then invented even better tools. You get the idea.
Okay, this brings us to what might be the most fascinating, and definitely the most recent chapter of our story. See, for a really long time, we kind of pictured human evolution as this simple, straight line. You know, that classic March of Progress image, with one species neatly replacing the last one. Well, it turns out that's completely wrong.
The reality was so much messier and way more interesting. It was a world filled with different kinds of humans all at the same time. While our direct ancestors, Homo sapiens, were evolving in Africa, you had the Neanderthals dominating Europe. Across Asia, you had the mysterious Denisovans. And get this, on islands in Southeast Asia, there were even these tiny human species, like the Hobbit of Indonesia and Homo luzonensis in the Philippines. So for a huge chunk of history, we were just one human branch among many. Yeah, this quote just nails it. Human evolution was not linear, but web-like. Our family tree isn't a tree at all. It's more like a tangled bush or a web. So that leads to the big question, right? What happened when our ancestors finally spread out of Africa and met these other human groups? Well, the answer, amazingly, is written inside of us, in our very own DNA.
And this is where the story gets really personal, because it's written in your DNA. Thanks to genetic sequencing, we now know for a fact that our Homo sapiens ancestors didn't just outcompete the Neanderthals, they interbred with them. That's right. So if your ancestry comes from anywhere outside of Africa, you, right now, are carrying between 1 and 4% Neanderthal DNA in your genome. How wild is that?
So what this tells us is that our story isn't one of simple conquest, of one group just replacing another. No, it's a story of connection. Our success as a species came not just from our own innovations, but from literally absorbing the genetic legacy of our closest, now extinct relatives. So, in a very, very real sense, we are all hybrids.
And that leaves us with a really profound final thought, doesn't it? Our 7-million-year journey was never a straight line. It was this complex, messy, beautiful web of interaction, separation, and then mixing. So if that's our past, what does that say about our future, in a world that's becoming more and more interconnected every single day? That right there is the power of understanding the incredible, tangled, and very much ongoing story of us.